Good day, doctor. My name is Neil J. My major number is 286586. Our group will present on the topic computing and the subtopic combination. Combination are a mathematical concept used to count the number of ways to choose subset of items from a larger set without considering the order of selection. The combination will focus on the selection of the item rather than their arrangement. Here is the formula of combination. N combination R equal to n factorial divided by R factorial multiplies n minus R factorial. N represents the total number of objects in a set, and R represents the number of chosen objects from the set. By understanding the combinations, we can determine the number of possible combinations or selection from a given set, which is helpful in solving many real-world and theoretical problems. Question 1. We have to select a committee of 4 senior students from 6 senior students and 2 junior students from 5 junior students. In order to calculate how many combinations, we implement the formula of combination. The total number of senior students is 6 and number of selected senior students is 4. So 6 combination 4, then we will get 15 selection. For junior student, 5 combination 2, then we get 10 selection. By using the multiplication principle, we use 15 multiply 10, then we get 150 selection. Part 2 of question 1. One of the 6 senior students is a cousin of one of the 5 junior students. Calculate the number of different committees which can be selected if at most one of these cousins is included. Here are all possible combinations. At most one included means none of the cousins, only senior cousin included, only the junior cousins included. For us to do easy calculation, we can calculate the combination that both of the cousins selected. After that, we use all selection to subtract it. Then we will know the number of committees which can be selected if at most one of these cousins is included. Since we already selected one student from senior student and one student from junior student that has cousin relation, so we remove them from the selection. We can calculate the both of cousin included, which is 5 combination 3 equal to 10 selection for senior students and 4 combination 1 equal to 4 selection for junior students. By using the multiplication principle, 10 multiply 4, then we will get 40 selection for both of the cousin included. In the end, we use the all selection, which is 150, minus both of the cousins included, which is 40. Then we will know the number of committees that at most one of the cousins included is 110. A committee of 8 people is to be chosen from 7 men and 5 women. Find the number of different committees that could be selected if the committees contain at least 3 men and at least 3 women. The image gives a clear idea about the question. At least 3 men and 3 women is fixed, which means we should find out the combination of others 2 people, whether it's men or women. There are 3 cases which the committees will contain at least 3 men and at least 3 women. Case 1 is 3 men and 5 women. Case 2 is 4 men and 4 women. Case 3 is 5 men and 3 women. From the image, we can know all 3 cases meet the requirement of at least 3 men and 3 women. The total number of men and women for all 3 cases is 8, which is correct. The left part is men and the right part is women. We calculate all 3 cases by using multiplication principle. For case 1, 7 combination 3 multiply 5 combination 5. Then we will get 35 ways. For case 2, 7 combination 4 multiply 5 combination 4. Then we will get 175 ways. For case 3, 7 combination 5 multiply 5 combination 3 equal to 210 ways. In the end, we just need to rewrite the formula. Then we calculate all cases, which is 35 plus 175 plus 210, then equal to 420 ways. Then we will get the number of committees that contain at least 3 men and 3 women. That's all from my part. Thank you.
Salam sejahtera and a very good day to doctors. My name is Tan Guan and my matrix number is 2x7471. And today I will going to continue the presentations on solving the probability questions by using the combinations. Now let's take a look on question 3. Here's the problems. A school has 3 concert tickets to give out randomly to a class of 18 boys and 15 girls. We need to find the number of ways that this can be done under 2 different conditions. And the first condition is 2 tickets are given to boys and 1 ticket is given to girls. And the second condition is at least 1 boy gets the tickets. In first scenarios, which is 2 tickets to boys and 1 ticket to girls. Now we will look into the solution step by step. For the step 1, we need to choose 2 boys from the total number of 18 boys. So the number of ways to choose 2 boys from 18 is 18 combinations 2, which is 153 ways. For the step 2, which is quite similar to the step 1, but now we need to choose 1 girl from 15 girls. So the number of ways to choose 1 girl from 15 is 15 combinations 1, which is 15 ways. And finally, we'll multiply the result that we obtain from the first and second steps to get the total number of ways to distribute the tickets. So in this case, we'll take 153 multiply with 15s, and we'll get the total number of 2,295 ways to distribute the tickets. For the second scenario, which is at least 1 boy wins a ticket. Actually, this is quite similar with the first scenarios. We'll break down the solutions into 3 simple steps. In this case, we need to find the total number of ways to distribute the tickets while ensuring that at least 1 boy gets tickets. So for the step 1, we need to calculate the total ways to distribute 3 tickets among 33 students. So to solve this, we'll be using the combinations formula. The number of ways to choose 3 students from the total number of 33 students is 33 combination 3, which is 5,456 ways. And now we'll proceed to the second step. We need to find the number of ways where no boys get the tickets. So to achieve this, we'll consider the cases where all the tickets goes to the girls, and we need to choose 3 girls from the total of 15 girls. So the number of ways to choose 3 girls from 15 is 15 combinations 3, which is 455 ways. And for the final step, which is step 3, we'll now can find the number of ways where at least 1 boy to get a ticket. To find this, we'll subtract the number of ways where no boys get a ticket from the total number of ways to distribute the tickets. So the number of ways where no boys get a ticket, which is 5,456 ways minus 455. So the result for at least 1 boy to get 1 ticket is 5,001 ways. Next, we will proceed to the questions 4, which is related to the team selections. And here's the questions. 2 teams, each of 4 students, are to be selected from a class of 14 students. Find the number of different ways the 2 teams may be selected if the first condition is there are no restrictions on the compositions of the teams. And the second condition is 1 team is content of boys only and the other teams is content of girls only. So in the first scenario, we'll need to select teams with no restrictions. We'll split the solutions into 3 simple steps to solve these questions. We will first identify the combinations for create first teams and then second teams, and finally the total number of ways to select the 2 teams. Now we'll look into the solution step by step. For the step 1, we'll choose 4 students from the total number of 14 students. So the number of ways for the first teams is 14 combinations 4, which is 1,001 ways. For the second step, we'll calculate the number of ways to select another 4 students from the remaining. Therefore, the number of ways to choose 4 students out of the remaining 10 students is 10 combinations 4, which is 210 ways. And finally, we'll multiply the result from step 1 and step 2 to get the total number of ways to select the 2 teams. So in this case, the total number of ways with no restrictions is 1,001, which is from team 1, multiplied with 210, which is the ways for team 2, and the result will be 210,000 and 210 ways. Next, we'll proceed to the second scenario. In this scenario, 1 team must contain boys only, and the other teams must contain girls only. For this scenario, we'll also split the solutions into 3 simple steps. For step 1, we'll calculate the number of ways to select 4 boys for the first teams, and the total number of boys in the class is 8. So the number of ways to choose 4 boys out of the 8 boys is 8 combinations 4, which is 70 ways. Next, we'll calculate the number of ways to select 4 girls for the second teams. So the number of ways to choose 4 girls out of 6 girls is 6 combinations 4, which is 15 ways. Finally, we'll multiply the result from step 1 and step 2 to get the total number of ways to select the 2 teams. And the number of ways with boys only teams and girls only teams is each 70 ways and also 15 ways for the girls. And the result will be 1,050. In conclusions, I would like to give credits to all our group members, which is New Wages and also me, Tan Conscience. Vijay acts as our group leaders, efficiently coordinated all activities, ensuring we stay on tracks. He also distributed the task fairly and also provided valuable insight during the brainstorming sessions. Me, as an active group member, I met the deadline and actively participate in discussions, offering constructive feedbacks to enhance the presentations. Together, we prepared 2 example questions for each members and showcasing a high degree of professionalism and leveraging our strengths to create well-rounded and informative presentations. Thank you.